Hi there YouTubers, it's Andre here from the DIY bench. Now the purpose of today's video is to show you how I am implementing my floating head for my plasma cutting machine. Okay, so I've taken the whole thing off and it really works well. So I'm just going to explain the different parts. Now here, as we all know, is the base plate for our Z-axis. This is, imagine the clamp being the plasma cutting head connected to the front. I've got plain standard threaded rod running from the back of a nut. It runs through a bearing with two plates I've made on my machine that will be permanently fixed to the Z-axis plate. The bearing sits inside. From there, it's got two nuts. I'm just going to show you on top. It's of the bearing. It's got a washer, and then it's got a short nut and a long nut. Pretty much, basically, two nuts like this. And all I've done is I've tightened them together so that it doesn't turn. It will just stay as one piece. And then what actually makes this floating head work is this section here. I've got a spring that does the floating, if you can call it that. And I've got a normal number 17 socket, and it's a deep socket. And the deep socket makes it possible for the head to float. So I've got a normal coupler here, and obviously on top here you will put your stepper motor. And I'm just going to explain this part here. Again, I've got a number 17 nut, and that runs through the long socket to the inside. Now it's a little dark here, but basically if I could pack this on the outside, it is basically a threaded rod that takes as number 17 nut. Once it's on top like that, it runs through the deep socket, and inside the deep socket I've got a nut like this sitting in like that. And the top of the threaded rod, I don't know if you can see the difference between the two. That one is machined down to accept the coupler, which is basically an 8mm. Now what was nice, the top nut fitted perfectly into the socket top. So I didn't have to worry about centering it. Obviously on the inside there is not that problem. But also it's tightened down, so this is one piece. So the way it works is the spring goes inside the long socket, and that goes into the long nut. And basically what happens is as soon as it hits the table, it floats like that. And the spring pushes it out and keeps the tension. So this part that holds the bearing here is fixed, remember. That doesn't move. The only part that moves when it hits the table is the plate that's going to hold your plasma cutter, the nut, and the threaded rod. And that goes through a bearing again. It will accept the threaded rod, which fits a number 17 nut, and it will just move through. And obviously here, the nut here keeps it from falling through all the way. but as soon as it presses, it will push through the bearing and against the spring in the long socket, and that is what keeps your head from damaging. So I've tested the whole thing, and it works nice. I just have a few more things I need to do. I need to drill a hole and fix it, and fix this to the Z-axis permanently. But it works. So I'll put it together, and I'll make another video of it actually as it's working. I think I've covered it all. Like I said, these two plates I just milled out on my machine, so they're exactly the same, and it just clamps the bearing on the inside to hold it. One more thing I've got to do is to fix this nut to the Z-axis plate. I've got a clamp holding it. Now I've already worked out that part. I don't want to weld it because I only have a stick welder, and as we know, stick welding, everything pulls and it's skew eventually as it cools down. So I've got another idea of doing that, but I'll put everything together and I'll make another video to show the floating axis, how it's working in the real world. And like I said, this is normal threaded rod. I did not use rod especially made for the Z-axis. I wanted to keep the rest of the cost as low as possible. Now I mean, I've got another machine that I use normal threaded rod on, and I've had good results with that. A little oil now and then will keep it from binding and from wearing too fast. So thank you very much. I'll put it together and I'll show it in practice. Cheers.